Welcome everyone. In this lesson we're going to be continuing on learning about UART, and in doing so we're actually going to take a look at the transmission that we identified on the router PCB that was taking place during boot up. Now to do so we're going to also be learning about the next tool in our hardware hacking toolkit, which is this device right here, a logic analyzer. So what logic analyzers allow us to do is to connect to the various communication points on a circuit or a PCB and then record any of the digital communications that are going on that channel as a capture. And then what we can do with that capture actually is with the software that comes with these analyzers is we can actually use it to decode those transmissions and figure out what's actually being transmitted. Now, that's as long as we're able to figure out what, protocol is being used and the various parameters that are taking place with that communication. Luckily for us, if we understand how the protocols work, then when we look at these captures, we can usually get a pretty good idea of what is going on and the different parameters that we'll need to set to decode them. So I think it's easiest if we just jump right into it and get this analyzer set up to capture the traffic from that router. Now, if you chose not to buy one of these, that's okay. You'll be able to follow along with most of this lesson. The great thing about the captures that you take with these is they can be saved for analysis later on. And I will save all of the captures that I take and make them available so you can open them up with the software still and follow along. So on this analyzer right here, we've got a nice picture that just demonstrates the pinouts of the pins right here. And it's just a transposition. So, if you were looking at the top of it like this, that's how these pins represent. So the two most important ones that we've got to take note of are the ground pins. Again, we need that ground for our communications to be able to work. So I'm going to hook my jumper up to that first, and I'm going to use the black wire just because that's generally the one in electronics that's used for ground, but you can really use whatever colors you want here. The colors do not matter at all. I'm going to connect my black one to the bottom, one of the bottom two pins. Either one is fine. There's two ground connections there. And then for the UART communication, we actually are only going to need to use one channel, and that's because we're just going to be listening to that transmission. Again, you can think of this as being like the receiver, and we're going to receive that transmission. So we just need the one channel. We're not going to be sending anything back or transmitting anything, so we don't need a second channel. And you can use whatever color you want for this. I would suggest you use channel 0, but realistically you can use any channel except for ground. The nice thing about channel 0 is you see we've got this power up here at the top and this channel 0 down here at the bottom. Well, these are LEDs, so when you plug this in, you're going to get the power indicating that it's turned on. And then this channel 0 LED, it will actually light up when there's communication on channel 0. And it only works specifically for that one channel with that indicator, but it will give you a good indication if you've got everything hooked up and you're actually getting data being transmitted. You'll see this channel 0 flashing. So that's why I'm going to use channel 0. And I got the purple one right here, so I'm going to use that. And it is this top left pin right here that is channel 0. Okay, so I've got it pushed in. Sometimes these pins can be a little sticky, so you just need to use a little bit of force, but I've got these two hooked up. So what I'm going to do now is I'll just bring the router over here, and we're going to hook them up to the router. Before I do that, though, I will just mention, you notice I don't have the protocol analyzer plugged in yet to computer, so don't plug that in yet. And also make sure your router isn't powered on when we're going to be plugging this in. We'll turn it on later once we've got everything set up on our computer and we're ready to make that capture. Okay, so I've got the router here, and I'll just bring these pins up nice and close so we can see them again. And again, we're just going to be connecting the ground pin. So that's this one, if I can just grab it right here. So the ground pin and then the transmit pin. So the black will go to the ground and then purple will go to transmit. I'm just going to hook those up quickly right now. Okay, so I've got those hooked up. If you're following along, make sure they're hooked up the same as well. Just do a quick double check. Make sure you've got black to the bottom ground pin of the analyzer, and then purple to channel 0, black to the ground on the router, and then purple to the transmit pin. I'm going to head over to my computer now, and we'll take a look at how to install the software and the drivers for this. And then after that's done, we'll plug the analyzer into the computer and then turn the router on. But just really important, until we do those, don't power on either of these. Okay, so I'm back over at my computer now, and you may have noticed in the past videos when I was on my computer that I'm using a Kali Linux machine, and I'm actually running this as a VM using VMware. Now, I'm not going to go over specifically how to set up a Kali VM in this. I'm going to assume if you're watching this through the TCM Academy that you're already familiar with how to set up that VM. I would suggest using Kali Linux because it's going to allow us to install or already have all the tools that we'll need for the rest of this course. So before we go on with this lesson, I just want to make a quick note about that. With that out of the way, we can get started on installing the software that we're going to need to connect up to our logic analyzer. And what we're going to be making use of is some software offered through the SIGROC project. So I'm just going to go check out their website right now. It is sigroc.org. Just like that. And if you want to read about their project, it's a pretty cool open source project that allows for us to have access to cheap logic analyzers like the one that we bought, and then make use of some open source firmware and then also their software that's going to connect to the logic analyzer and allow us to actually analyze those captures. So I just went to this website to check it out. We can actually get their software through the apt-get repository on Kali Linux. So what I'm going to do next is we'll just open up a terminal. Always a good idea to update your repositories first, so I'm just going to do that right now. And I'll let this run through. Okay, so in order to install this through apt-get, it's going to be sudo apt-get -y install, and then it's just sigroc. Perfect, so it looks like it is installed. Now, the actual specific software we're going to be making use of to view the logic captures and also make those captures is called PulseView. So that is the software that's created through the SIGROC project. So I'm just going to launch that up right now. All right, so this is the software we're going to be getting used to using to take captures with our logic analyzer and then also to analyze them. So I have my router powered off now, as you should as well, and I also have my logic analyzer not connected to my computer through USB. But what we can do now is we're going to connect the logic analyzer to our computer through USB. And then if you are using a VM like me, then you'll have to make sure you connect that USB device to your VM as opposed to the host machine. So I'm just going to plug in the USB cable right now to my logic analyzer. All right, and it should show up as this Lakeview USB device, and it's perfect that it's just popping up for me. So I'm going to click OK. So if you don't get that pop up, for me, I'm on VMware Pro. So if I come up here and I do the drop down here and go VM and then removable devices, then you can connect or disconnect it through here. So it's going to show up as this Lakeview Logic. And it's similar if you're not on the Pro VMware. And then it's also very similar if you're using VirtualBox. So remember to connect those. So I'm just going to make sure mine is connected right now. So this logic analyzer already actually comes loaded with one of the open source firmwares that's developed through the SIGROC project, which is the FX2LAFW firmware. And the reason we need to know that is we're going to need to set up PulseView to communicate with our new device. So what we're going to do is just go up here and we're going to click on demo device in the drop down here, and we're going to connect to a device. And then we're going to have to choose a driver. So from this drop down here, we're going to go and we're going to pick this FX2 LAFW generic driver for FX2 based LAs. So we'll click on it here. And then we'll just leave it selected as USB. We have it connected through the USB. And then we're just going to click on scan for devices. And it's going to be this one right here. This Saleya Logic with 8 channels is the one that we are going to grab. So I'm not entirely sure why the device is named as this. This is the name of another company that makes logic analyzers. So I don't know if these makers at one time were trying to pass this off as a clone or not, but we're going to be using all of the open source drivers and this open source software with it. So you can just click OK and it's going to add that device. Now, if you get an error at this point about the device not being supported or there's an issue connecting to the device, I've noticed that if you have the USB for this logic analyzer plugged in through a USB hub or something like that, it really doesn't like it. So make sure if you can to just try and plug this directly into the USB on your computer and try not to have any hubs, or in my case, I had a KVM switch that I was plugging into and it didn't seem to like that. So with our device connected, we're actually almost ready to start taking our first capture. But what we're going to do first is we're just going to make 2 quick changes here. So the first one is just how many samples we're going to take. And we're going to up this because this is just going to run for 1 second and we want to take a capture longer than a second. So I usually just put it at 100. And then if we use less than that, then that's okay. It just won't stop it ahead of time. If you notice that you're running a capture and it's just stopping, you probably forgot to update this, because at 1M, the default, it's just going to run for a second and then stop, which isn't going to be long enough for our scenario. So the next thing we're going to change here is this frequency that we're going to sample at. 20 kilohertz is going to be a little too low for us. I'm going to up it to 1 megahertz. Our device will support up to 24 megahertz, the logic analyzer that we have, but in testing, I found that it honestly, it can't always hold up to 24 megahertz. And what will happen is it will just stop the capture at that point. 1 megahertz is going to be more than enough for this UART capture that we're about to take. Okay, so we're almost ready now to start our capture. And what we're trying to capture here is that boot up transmission on the router. So we're going to want to make sure we have the router ready to be powered on shortly after we start the capture. So what I've done in this case is I have my power brick, it's plugged into the wall, and I just have the end of that near the router ready to plug it in. And I've already got my cables hooked up from the UART header that we attached on the router to the logic analyzer, and those are connected up how we did in the last video. So all I need to do is I'm going to hit the run, and then I'm going to plug in my router. So what we're going to do is, this is to start the capture, so I'm just going to start the capture right now, and then very shortly after, I'm going to plug in my router. Okay, and if you just slide this bar over here, you can see right here, this is where I powered on the router. And then as I slide over, you can start to see these blips. And if we zoom in on them, so I'm just using my mouse scroll wheel, we start to get some transmissions that we're capturing. So I probably had it run long enough now, so I'm just going to stop it here. And we now have our very first logic analyzer capture of our UART signal. So if you, for whatever reason, were not able to get this working, or you chose not to purchase a logic analyzer, what I'm going to do right now is I'm actually just going to save this capture, and then we'll end the video here. And in the next video, we will open up this capture and we'll take a look at how we can decode this UART signal in some of the different characteristics of UART. So good idea to always save these just for our reporting and so we can have them later. And to save it, we're actually just going to come up here to the save icon. I'm going to click save. And we'll see here it defaults as this srzip session file. So that's the one that we want to leave it as. And I'm just going to save it on my desktop now so I can find it. And we'll just call this router. Actually, we should name it TP-Link router UART boot up capture. And I will save that. Perfect. So I'll end this video here and I'll see you over in the next one where we open up that capture and then take a look at decoding that UART transmission.